Hello and welcome to Dotnet with Sikhen, and our today's topic is Abstraction in C#, the fourth pillar of object-oriented programming. So let's get started. Abstraction. It shows the essential features and hides the unnecessary details. Now what does it mean? So let's take an example. When you press the power button of the TV remote, TV gets turned on, right? So what is the essential thing here that you should know, that is like whether the TV is plugged in or not, and whether the remote is working or not. And when you press the power button of the remote, then the TV gets turned on, right? And you don't need to know like how internally the circuits of the TV works so that it turns on, right? It is not necessary for you to know all these things. Only thing is that you should know like how to press the power button of the remote. Let's take another example. When you enter the pin at ATM, you get the money, right? And you don't care about how the ATM internally works so that it withdraw the money and it dispatch to the user. You don't care about this, right? The logics and programming, everything is written inside that ATM, and you don't care about that. Only thing is that you should know like how to enter the pin and how to get the money. That's it. Here I have taken another example, that is the shape example, and here you can see I have created one class, that is abstract class shape, and it has one property, that is the name, and one abstract method, that is the calculate area. And here you don't have the implementation, so basically the abstract method does not have the implementation. And we have two methods here. One is the display, which displays the like drawing and then shape and shape name here, and then another is the virtual method, like it describes the basically the area, right? It describes about the area. So here you can see we don't have the implementation of calculate area. Now who will give the implementation? Obviously the child class, right? Let's take another example that is already we have seen in the interface section in our previous videos. If you have not watched, please go through that. So here also you can see we have one interface, that is iAnimal, and then it has the name of the animal, and also we have the speak method. But you can see here we don't have any implementation, or you can say interface method does not have the implementation, right? So in one line, abstraction is achieved either through abstract class or interface. So either we can use the interface or abstract class to achieve this abstractions. And one more point here, like you are not allowed to create an instance of either abstract class or interface. So already we have seen like we cannot create the object of interface, and also here you cannot create an object of abstract class also. So let's quickly jump into the Visual Studio and look at it in action. Now here same abstract class I have created here. So you can see this is the property name, and we have the abstract method, that is the calculate area, and the abstract keyword is used for marking this class as an abstract, or the method as an abstract method, right? And here you can see there is no implementation. So the responsibility of the child class to must give the implementation. And now we have another methods, normal methods like display and describe. Here I have kept this describe method as a virtual so that we can override it, right? So here there are two classes I have created. One is the circle, and which is inheriting from shape, and you can see circle has its own radius, and then it has the implementation of that method. So here the calculate area is a base class method, but that is abstract, so abstract keyword is used, and while implementing in the child class you must provide the override keyword, so that the calculate area, which is an abstract method in the base class, is getting overridden in child class, and you can provide the implementation. So this is all about the circle class, and in the same way we have the rectangle also. And rectangle class is inheriting from shape, and it has its own length and breadth. And here also we have the calculate area, length into breadth, which is the area of the rectangle. And you can see the virtual method, that is what we have in the shape class described. We have overridden it here, right? So this is the polymorphic way of doing the things, and you can describe it. You can provide some other things like it's a rectangle with length this and breadth this, and then also you can call the base class described on, right? So again, when we say base class described on, it means that this describe is from shape on, right? And then here we have the description, and then you internally call this calculate area. But most importantly, what you need to understand here is like the abstraction, right? This shape class does not provide the implementation, and when you create, or you can say like the reference of this shape class, and which will point to the object of child class, then you don't care about like how internally the child class has implemented this area, right? So let's go to the main method and look at it, how it works. So I have created one array of shapes, and there are two shapes here. One is the circle and another is the rectangle, and we have also provided the details, for example the name of the circle and then name of the rectangle. And here also we have provided the radius is 5, and in rectangle we have provided length and breadth. Okay, and in the loop you can see like shaping shapes, and here we can call this display and describe method, right? So when we call this describe method, then it goes to this base one, right? And if it is not overridden, then it goes to the base one, or if it is overridden, then it will go to the child one. In case of rectangle, here you can see, so it will go to this place, and then it will call the base one, right? So let's run it and see the result. So I'm putting one breakpoint here. Okay, so now we have shape array, and there are two shapes here, circle, and then we have you can say the rectangles, right? So circle and rectangles are there, and let's rotate this one through the loop. And if I press F11 here, then I on this base class display method, and it displays basically drawing circle. And then when I press F11 again inside this, so I am in the shape class, and then in describe method, right? And here also it describes like name, but we have not given any implementation in this shape, so where it will go? So let's press F11 again, and now you can see it goes in the calculate area of the circle class, right? And here, because you have overridden it, and you have must overridden it, right? So here now it calculates the area, and then it displays here, or you can say it gives the information. So this is all about the circle. Now let's move to the rectangle one. So if I press F11 here, then you can see it goes to the overridden method of the describe one, right? Not the virtual one, which is in shape class. And then it prints it, and then also it calls to the base one, right? So if you press F11, then it goes to the describe method of the shape class, and here it calculates it, right? So again, when you press F11, then it goes to the calculate area of its own, not of its own, but yeah, overridden method of the shape class, right? And then here it returns length into breadth. So here the only thing that you need to know, like how to call that describe method, and you don't care about how internally this describe calls the calculate, and it calculates the basically area of the shape, right? So this is the abstraction. I hope you understood this concept. Yeah, so that's it for today, and I will see you in the next video. Thank you.